Good afternoon, ladies and gentlemen. Thank you for attending Improving's January 15th virtual Lunch and Learn. Before we start, I want to inform you about a feature of the presentation that will make the session more interactive. Please make note of the question mark icon at the upper right of the presentation screen. Clicking that icon will open the question and answer feature, which allows you to send the moderator questions to be delivered to our insightful presenter at the appropriate time. Speaking of insightful presenters, I am proud to present Devlin Liles, who's president at Improving Houston. Today, Devlin will be sharing a webinar entitled Solution Architecture for Future Frameworks. The floor is all yours, Devlin.
Thanks, Sherman. So I will warn you all ahead of time. I have had a great morning. I've had 3 cups of tea and I'm a little sassy. So we may be having a lot of fun today. So I'm Devlin Liles. If you haven't met me, this is everything you need to know about me. I am a passionate geek. And so we're going to be talking about kind of how that applies in the space of kind of an unknown future. I've brought my crystal ball. I've brought my tarot cards. I even have the little table. So let's get started. Now, the first piece of this is, why in the world are we here talking? And I like to picture the discussion that we had that spurred the idea for this talk. It's like this roundtable discussion where we were at a whiteboard and we were collaborating. It was more like we'll say a very vigorous religious debate in which we were discussing what the next thing would be. And like all vigorous debates, we broke out into song. And we're like, what's the next great software revolution? And then, we said I wasn't throwing away my shot. One of the guys said, wait for it, it's going to be AI. It was a whole big thing. But in reality, we were talking about what are the things that we've talked about in the future, the things that we've said, oh, this is gonna revolutionize everything. And it hasn't quite gotten there. And these were some of the topics that came up in that conversation. It's like blockchain. Blockchain's going to revolutionize everything. I remember that in 2013. AR, VR, extended reality, that whole big area, 2014. Right about that same time, I was thoroughly convinced Windows Phone was going to take down the iPhone. So it turns out my crystal ball is cracked. I apologize. Definitely lost that bet to 2 dear friends, Tom and Tim. They bet me that Windows Phone was just going to be dead, and they were right. Artificial intelligence, we've been hearing about how it's going to change everything and it's going to destroy jobs for 50 years. Self-driving cars, I remember kind of passionately being on this bandwagon in 2009. Personalized healthcare, where you could just a drop of blood and my genetic history, and the doctor would know exactly what's going on, the exact right prescription, the exact right treatment, 2004. Programming of biological cells, custom targeted drug treatments, 2002. 4 years ago, edge and serverless, everything's going serverless. In 5 years, nobody's going to have servers. And there are tons and tons and tons more of these stories. Now, you can look at this entire list and go, you know what? Some of that has come true. And it has. I've got a great VR setup at my house. We use it to play Beat Saber. Artificial intelligence guarantees that I only see news I agree with. Autonomous driving works pretty well as long as you're going straight, not changing speed, and are on a well-lined road. Personalized healthcare is a thing. They target cancer and drug treatments all the time. Programming of biological cells took a massive leap forward with CRISPR. But none of these revolutions ended up the way we had expected them to, or these grand visions and marketing hype. So how do we plan for an uncertain future? How do we deal with the fact that the frameworks we're going to be using, the applications we're going to be building, are going to go through a lot of change, and protect ourselves from that change without buying into the next great story that's probably going to look a lot different than the marketing and sales pieces say it should? My approach to this has been build every application for evolution, but very, very few for revolution. What I mean by that is how we approach frameworks. We should build our application structures and our frameworks knowing that certain things will change, that they will evolve over time. The next version of Angular will come out, or React or Vue. We might even switch between React and Vue and Angular, right? We may add APIs, we may add new technologies, new offerings. And how do we make that as low friction and low cost as possible? But I always kind of perk up my ears when I hear somebody that's like, we should write an API on top of our database in case we want to change databases. Like, what business decision would drive you to change databases? Because going from SQL to NoSQL has advantages. It also has disadvantages. And it is not a small amount of effort. That API is not going to save you from the fact that those two systems function very differently. That API is not going to save you from the reporting implications of that decision or the BI of that decision. It's not going to change that every one of your objects you're going to need to treat a little bit differently. And so your design paradigms change. So should we really spend the time to build that API, or is that simply the thing that changes if we make that decision? It's the rounding error, or as one of my old friends taught me, the bike shed. Now, if you're not familiar with this reference, a bike shed is a term referring to the little easy to understand thing that we talk about, because there's something much more expansive that requires expertise that's hard to talk about. It's very nuanced. And it's in reference to, imagine that you're on the board of directors and you're supposed to approve $10 billion to build a nuclear power plant. An incredible feat of engineering and government relation and all these things. And everything's been planned and they're just waiting for the approval. They present the plans, they present it all, and they go, you know, we're going to have top-notch security. And we really care about our people too. And so we've included a fitness facility and a shed out in front of the guard shack so that folks can park their bicycles as part of our, our worker wellness program. And everybody in the room starts talking about how big the bike shed is and why you should have the bike shed. And maybe that's not a needed feature. When the cost of the bike shed is a rounding error on a rounding error for the overall cost of the project, because it's the easy to understand and easy to debate problems. We often fall into this in architecture. That API on top of a database is a rounding error on the effort it would take to change those database design paradigms and to move all of the data and to deal with history and preload and migration. It's a rounding error, but we end up talking about it as if it's the entirety of the problem. And so that's what I mean when we say build every application for evolution, but very few for revolutionary change. Now, if I look at this as it applies to all of the things that we've seen over the last, several decades to several centuries that have gone obsolete, what are the things that we need to consider? Now, VHS tapes did a very good job for their time in their distribution, their cost of delivery of media into a home. Now, there was a better product called Betamax. Betamax lost. It could store more data, it could deal with better quality, but the ease and cost of production, VHS won. Now, ultimately, VHS is obsolete because incrementally, cameras got better and the images got better and the size of the movie got bigger and bigger and bigger because of these things. And the sound editing got better. And we went from having 2-channel sound for stereo speakers on a TV to having 5.1, 7.1, 9.2, THX, DTS, Dolby surround sound. All of these things started happening. And the size of the files got much bigger. But it wasn't overnight. It wasn't a revolutionary change. It was incremental. And so we went from VHS to high density VHS. Then we went from that to DVD. And then we went from that to Blu-ray. And then we went from that to digital delivery. And so we incrementally got to where we are. It wasn't a, magic, gone. Same thing with cassette tapes. Same evolution, same progression to CDs, to MP3 players, to digital streaming of high fidelity sound. There are some applications that we build today that, because of the evolution of everything around them, will no longer be worth it, and new technology will come out that is just better. That's okay. That's not a failure of the design of VHS or the cassette. It served its purpose. And so when we're looking at architecture, we don't need to have all of our applications and all of our architectural decisions live forever. Think about the telephone system that originally started with operators, kind of hand switching cables to connect people. And then we ended up with automated operation, where we would auto wire and route. And then we ended up with voice over IP. And now we've got cellular and digital systems that are wireless and we carry them around in our pocket. But ultimately, the speaker and the microphone haven't changed. The idea of the telephone, its conceptual design, hasn't changed. All we've changed is the mode by which we get information in and out and all the other things it can do. Because your cell phone is now a computer that makes phone calls. But the phone portion of it really hasn't changed. And so that's a design that stands over the course of time because it didn't try to be more than one thing, right? A mobile phone, the phone piece of it tried to do one job and tried to do it incredibly well. Now the counterpoint to that is the abacus, right? I don't know that I would download and use a digital abacus because the user interface of the requirements of an abacus is now so easily doable with graphing calculators and built-in calculators, and our processing power is so monumentally more that that user interface, that design paradigm no longer makes sense. And so it just goes away. It doesn't even evolve. It is replaced by something that is hands down better that the inventor of the abacus could never have foreseen. And you can look at this in all different ways. Look at the Model T that eventually becomes the Audi R8 and the Bugatti Veyron. There's no way that in 1912, 1907, we're looking at the Model T and the Model A and going, you know what? We're going to build a car that can do 300 miles an hour. When they were terrified of going more than 20 miles an hour and the effects that would have on a person's health. So we don't need to predict the really crazy far off future because we can't control it. So how do we deal with the near future? Now, these things that we consider are typically the illities. Now, anybody that's ever sat down and done kind of an architectural analysis, maintainability, supportability, repeatability, reliability, illity, and it just keeps going. Which of these is most important? So I'd like to ask in the QA function, go ahead and just send in a note. Be like, accuracy, accountability, testability, whatever your personal favorite, the one you think is the most important, go ahead and put that one in there. Now, my absolute favorite in this is effectiveness. I know it's not an illity, sorry. It's effectiveness. How effectively does the application solve the business problem? Maintainability, all of those things. We have seen hard to use, poorly maintainable applications thrive. My favorite punchline to that is SAP. I haven't met somebody that goes, SAP is the most usable system I've ever touched. It's not the most customizable, but it does often solve a problem in a kind of beautiful way. And so you get these, the thing we value may change over time. So what are some of the favorites from the crowd, Sherman? Or yours personally?
Usability is one that's come in, but you kind of stole mine. I always look for effectiveness, but also efficiency is something I always take into consideration.
Absolutely. Now, there's a couple on here that where you're like, you know what? Affordability. If I'm starting up a company and I've only got $10,000 before I've maxed out every credit card, I've taken a loan on my house, affordability is way more important to me than if I'm Tesla, right? If I'm a financial system, auditability isn't optional. It's like, no, that's a hardline requirement. So based on who we are and where we're at in the progression of the company and the business, Each of these is going to have different values. It depends. And so when we look at this, and we know that we can't predict the far future, we know that everybody's going to have a different opinion of what that future looks like, and we know that it depends on the business problem, let's dive in to getting to know what those business problems are. Now, what are some of the major architectural eras? Right? Use the same QA function. My example is the mainframe era. In the mainframe era, we had these large central repositories that you could telnet into from a dumb terminal or something like that, and you could connect in and you'd have the ability to talk to the mainframe. Your terminal really had no idea what was happening. It was simply sending a question or a request or a command and getting back a response and showing it to you. It did nothing else. Now, that was driven because it was really expensive to build systems that could do any kind of reasonable amount of processing. They were as big as the room I'm standing in. And I couldn't put one of those in every home. And so to deal with that restriction, we would lease time on the different mainframes. I remember my high school and my college, we actually had a mainframe that we were able to use and those kind of things, even though right next to we had a PC. And it was history of computing, and it was like, oh, I can telnet into it. I remember having those kind of moments of realizing I have more power in my cell phone than put a man on the moon. I've heard that a bunch of different times. The accessibility of computing power changed the way we deal with major architectural decisions. What are some of the other eras that you can come to think of? Another one I hear frequently is the PC era, right? Where everything was a thick client application. It ran on your PC, right? The Windows 3.1 to Windows 95, Windows 98, Windows 2000, Windows 2000 NT. You had Mac OS at the same time. You had the Linux evolution, right? Sun OS. But it was very much, I'm going to write an application for this operating system. And it's going to run on machines that can run that operating system. And it's going to do everything it needs to do here. It might ship its data off, either connecting to a database somewhere else or synchronizing and shipping its data off in like batch processing, but it was on the machine. Then we have the web era, where everything moved to kind of the website. And the joke was every application will end up in JavaScript, even if it shouldn't be, because everybody was using Node and Mean and Mern and all that. We're still a little bit in that era. So what are some of the others? What are some of the bigger kind of social moves that we've seen in technology?
When we got the internet, cloud, and mobile.
Oh, I love that. Cloud and mobile, fantastic. Right, the mobile era, when everybody wanted to have a mobile app, even if their mobile app really didn't do anything, they're like, no, we got to have a mobile app. It's got to be in the app store. I'm losing credibility. We got to be in the app store, right? Or the cloud era, and we're still a little in that cloud era, right? It's evolving, right? The cloud was this mystical thing. I remember there was an old meme where the guy with the big IBM logo jumps into the conference room and he goes, to the cloud. It's like, yes, what does that mean? And so now we've come to realize the cloud is really someone else's data center, right? Somebody else's servers. And so infrastructure as a service became rank and file normal. And then it was like, okay, well, then we've got platform as a service, and then we've got software as a service. And now we've got AI as a service and messaging as a service, insert ad nauseum as a service. And so we've seen these kind of evolutions. So I broke these down into, and along with others, into an evolutionary cycle for the complexity of solutions. Because as we grow functionality, there's kind of a natural pull to solve the problems of today. And those solutions create tomorrow's problems that we then have to go solve. But rather than take this as an abstract of consolidation and fragmentation and then the offering of a service, let's break it into its pieces. So when I fragment a system, when I went from kind of that standardized mainframe to PCs, I removed a decent amount of change impedance because I didn't have to upgrade or change the one main node. It didn't have to carry all the load. My application that was this big monolith didn't have to change all at once. So change impedance went down. The complexity of governance and control as the system fragments goes down. If I've got an accounting system and a shipping system and an inventory system, that's very different than if I have one system running my business, because there's ability to move in those different areas. It became easier to optimize for performance because we didn't have to manage the performance of a single system. We could actually manage performance by democratizing that across its pieces, right? Same thing, innovation in different areas became easier, and it became easier to learn the pieces of that system rather than trying to understand the whole system and how it all interconnected. But to buy those complexity decreases, we also bought an increase. We started using different tools. It was like, okay, previously it was just DB2, now it's COBOL and DB2, and now it's, oh, well, we're going to centralize our data into Sybase and use Visual Fox Pro and those kind of things. So we started seeing a lot more tool variation. We started seeing different patterns because in those different systems, the patterns emerging were tailored to the specific areas that they were dealing with. Reporting became more complex because we had to kind of collate and centralize those pieces of those systems to get that cross-functional reporting even more difficult. And that's where you see the evolution of data warehousing and data marting and data lake and data lake house and all that fun stuff now. And the cost to integrate the system, which previously was just part of the cost of building it, is now this separate idea. And so system cost modeling, the ability to know how much the system costs to build and to run, became much more difficult. Now, I applied that to the mainframe space, but if I take this out of kind of cloud as a infrastructure as a service and we start fragmenting into platform as a service, it became easier to cycle the messaging system by itself or the queuing system or the data storage system by itself. So change impedance lowered. The governance and control became system specific to each of those services. Performance improvement can be optimized. You could scale a single piece of a system. And so you'll notice that this evolution applies no matter which of those eras you're transitioning between. And the same thing is true when we go into the next evolution piece, is you'll see that this continues to evolve. The complexity of these as a service, right? You get pattern inconsistency throughout the system. That decreases because as a service, you're defining the patterns that people can use to interact with it. Now, if I don't like those patterns, I don't buy the service. And the integration design is predetermined. Here's the service, here's how you integrate with it. We don't have somebody accidentally going, oh, I need to integrate these systems, so I'm going to just read from your databases and my integration breaks when you update the database because you didn't know I was reading your database. It becomes easier to optimize for performance even beyond that fragmented system because we can determine how the users use the system. If there's certain things that are not performant, we can simply not allow them, right? If I do a large scale raw select from certain NoSQL databases, they just truncate the response as a way to protect the performance of that service offering, right? It's easier to get what combinational learning, where a user using my service, I can see what they're doing and I can learn from how they're using it to bring new innovation to the table. And I can report and do analytics on the system. All of these get easier. But by those decreases of complexity, I now have multiple products to serve multiple niches, and so the complexity increases. Multifunction reporting continues to increase. And now there are entire service offerings doing a lot of that data aggregation. The flexibility of the offering, the complexity in that grows because the more flexible the offering, the less as a service it feels. This is the infinite configurability, flexibility of something like a SharePoint or an SAP. System cost modeling becomes even more complex when we start looking at by usage, by consumption, right? Predicting exactly what a system's going to cost to run is something that people actually now get certified in, right? You can get a certification in AWS and GCP and Azure for understanding their cost models. Complexity of misuse becomes a harder thing because as people start using those services and they start trying to do more and more with them, the detection of what normal use versus misuse are becomes harder. And the ramp up time by learning hundreds of different frameworks gets even more complex. And so in response to all of those complexities, you start seeing a pull towards centralization or consolidation. And we're seeing this pull today because of where we're at in this evolution as an industry, where, yeah, AWS may have a better answer for that one product, and GCP may have a better answer for that one product, but the other half of our stuff is in Azure. So even though Azure's answer is second best in a couple of places, we're going to use them because it'll reduce our complexity, right? It allows us to standardize. It gives us cross-functioning reporting if we stay inside that centralized and consolidated model. It allows me to manage my usage in one place and makes it easier. Cost modeling becomes easier. But now we've gone back and increased the impedance to change. We've decreased the speed of innovation and increased the complexity, the cost of innovation. And now we've increased the cost of ramp up time again, because as we consolidate, the complexity of the overall and the interconnected pieces of it become another problem to tackle, and we start the whole cycle over again. Now, when we talk about architectural design, it's important to note where we are in this evolution. Because if I've got a large centralized application, then I need to target my innovation. I need to target my changes to tackle the complexity that it creates, while taking advantage of the places where it's going to serve complexity very well. And then I need to map those out against the business problems I'm tackling. So it's all really interesting, and I've kind of pontificated beautifully, by the way. Great poetry. My prose is on point. Now, what does that mean? So let's take a look at it. What is good complexity for the following solution? Let's assume that we're writing software and building a solution for a tire manufacturing company. They build road tires. Now, some of the known things in that is that it's a cost-sensitive industry. You can buy tires from dozens of different brands at this point. They need a reliable and consistent process. It needs to be easy to use because in the manufacturing places, the harder the system is to use, the less likely it is to be used. Most of the evolution in that system comes from new polymers, new construction, those kind of things. Inventory management's a big deal. And being able to figure out later if 2 years from now there's a defect in that tire in our design process or something like that by tracking the data of failures kind of later on. But what areas might be less important? When we look at it and go, we don't need complexity for that. In some cases in this, if I'm a manufacturing company and I'm running hardware, I'm running the press molds and the volumetric analyzers and the rubber pour, does that need to be cloud connected? Probably not. An on-prem server gives me some reliability. Okay, now I'm looking at ops costs, reliability numbers, those kind of things. Do I need to be applying AI models to figure out the best possible way to optimize labor for my production output? It'd be cool, but does it have a return on that investment? If it takes me $200,000 to build that model, it better have a pretty big payoff, because at a 10 cent per tire increase, I got to make a lot of tires to pay that back and start earning from it. and every piece of maintenance that I have to pay makes the cost of the overall system really important. And so I may not chase the most cutting edge technology. I might not have all of my manufacturing tools connected with, centralized control and those kind of things, because the maintenance costs may destroy any ROI of that system. So are there some areas in this that we could potentially safely ignore for future evolution? What about robotic manufacturing? If I'm a tire manufacturer, can I safely ignore that? Probably not. We talk about the cost of labor, you talk about the cost of materials. If I can build a low maintenance cost robotic solution, that's going to be important to me. So I'm probably going to need to pay attention to that one. Can I pretty safely ignore, staying right on the bleeding edge of web frameworks? Probably. I just need something that's going to live for a long time and be stable. So I might use something just like raw MVC. Might not be the prettiest thing in the world, but it'll be optimized for what I want, which is consistency, reliability, and low maintenance. Now, if 5 years from now I have to upgrade the web UI to a new version of something, okay. And so architecturally, if I'm looking at this space, I'm going to look at the things that are going to reduce the complexities that are inherent in the industry, right? I need to make sure that, we can track batches in manufacturing so that if there's a recall, we know exactly where we shipped all those things. Inventory management and making sure that we know where all the tires are. We've got a good process for allocating those. There's a good financial track of our costs, our labor optimizations, right? We're probably going to need some kind of reporting to make sure that we're focused on those. Probably not going to aim for kind of the bleeding edge, or even probably current. We'll probably go current -1 on the web technologies and frameworks. And so it gives me a target space to build the architectural patterns and design ideas that'll influence heavily my framework choices. Now, before I move on, give a chance, are there any questions about this? They're like, hey, how would you deal with X, Y, and Z?
There aren't any right now, but I will let you know when as soon as they come in.
And let's take a look at something like inventory management, warehousing, logistics, right? With Amazon and with all of the at-home ordering and shipping and everything else, this has become a big thing in the last year and a half. And it was already burgeoning as an area for huge investment. Now, there's some known complexities to this one as well. Storage and picking efficiency, because you've got labor inside the warehouse moving around. You're going to want to make sure that those dollars and those folks are getting the most done with the least effort. You're going to want to make sure that you don't have product going bad in the shelves if it's spoiling. You also want to make sure that the oldest stuff in the warehouse is the stuff that gets shipped out first, even if it's a stable product, because it reduces the spread of a recall. We need to know if products are available, because every time I go onto a website and I go, hey, click, 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 I need to know, is it in inventory or is it a lead time, right? If you go right now and try and buy a Peloton, you're going to have the little thing that says, hey, it's going to be a couple of weeks. That kind of idea. Because we also want to know if we have on-time order shipping, right? Am I able to ship what they ordered, exactly what they ordered, and on time? Which means I'm going to need pretty good analytics and intelligence as those things change in real time so that I can inform my users. And that's going to heavily influence the architectural decisions. And it is a thin margin, cost-centric industry. High volume, low margin. Now, what are areas that are less important? Full automation in robotics, probably not a big deal. And when I say probably not a big deal, it is because of the cost of fully automating. Now, don't get me wrong, if I was designing this system, automation, process automation, as much robotic automation as made sense, would totally be a part of the plan. But I probably not looking to make sure there are no humans in the warehouse, right? It's the automation of, all right, so I scanned this thing, it sent a message, it notified these people, and boom, it gets me to the outcome without the manual interventions and those kind of things. I've probably got messaging systems and dashboards and those kind of things to make the warehouse as effective as possible. I'm going to have mobile telemetry to make sure that the handhelds or the mobile devices or the kind of ruggedized tablets that we're using for the in-warehouse folks are trackable, and we can push data to them so that if a new order comes in that's got to be shipped out immediately, somebody gets an alert, but not everybody, and they go and they do that thing. Now, are there some areas in this that we can kind of safely ignore for future evolution? Probably, right? Now, there's been a lot of innovation in the logistics and warehousing space over the last few years, but a few things haven't changed. Things still come in and out, primarily in the United States, in big rig trucks. Trucks move the world for the US. And then the last mile logistics are still going to be smaller vehicles delivered out by hand for the foreseeable future. Do I need to build my application that assumes that large scale drones are going to take over all delivery? Probably not. We can cross that bridge when we get closer to it. And so we can ignore some of those kind of, okay, I don't have to worry about, plugging my application into the FAA or into weather or wind patterns, those kind of things. Right, I can use a standard logistics module that tracks trucks and manifests and bills of lading. Right, I can probably get an off-the-shelf documentation and audit package because that's a pretty baked and known problem. So we can start focusing only in on the complexity that matters. Now that we've gone, all right, so let's look at the future that we can predict. Let's look at the type of change that we can predict. And then let's focus that in on the areas that will make the most impact for what we're building. The next step is to move into the frameworks. And we're going to pick two and let the zealot debates begin. Microservices versus monoliths. Or the kind of next evolution, which is the cloud platform native. Now, if you're like me, you have one of the three default answers. Microservice, all the things. Everything needs to be a microservices. My microservices have microservices. And then you've got the old guy there with the COBOL and DB2 going, you young whippersnappers haven't seen good software. Right? Or AWS is all you'll ever need. How have you not built everything on Lambda? In reality, it's probably a little more nuanced. And we start looking at what scale do you need and what's the rate of change? Because I don't need cloud platform native infinite scalability if for the past 30 years, I've had the same throughput on my system that I plan to have in the next 30 years, plus or minus 5–10%. Like the ability to quintuple my throughput overnight is an ability I'm just not going to use, right? How many developers are working on the system concurrently? If I've got one developer, then I might not want to have that one developer have to work on 40 services that are all interconnected, because the mental process of switching between all those contexts would actually slow me down and increase the cost of the project. But if I've got 25 developers working on an interconnected system, I probably don't want all of those in one code base on one branch in one application that all compiles together, because it'll increase my cost and slow productivity. And then the kind of the obvious question for microservices, for cloud native, all that is, do I have a team that's experienced with messaging and integration patterns? Because when we take that consolidated monolith and we fragment it, integration becomes harder. Cross-function reporting and integration becomes even more difficult. And so if my team knows nothing of those patterns, I need to look at the cost to train them and get them up to speed versus the cost of doing it the way they know. And then is the solution going to be hosted on-prem or in the cloud? And is that likely to change? I've heard the term cloud agnostic, which if I'm building like Docker containers and Kubernetes or something like that, I can pretty easily move those unless I'm using cloud native pieces. But what if I'm running on-prem and I don't have any plans to change it because I've got security contracts that require it to be in my data centers under lock and key that I own, right? DoD or something like that. Then trying to architect for cloud native pieces probably doesn't make sense. So when we scale all these things in, you go, okay, we're going to take a microservices approach because we expect 5x scale in the next few years. We've got a team of 20 developers that are going to be working on it. We've got a pretty good central team that's got experience with messaging and integration, but we are debating on switching cloud platforms in the next couple of years. So we're going to go microservices, but not cloud native. So as you weigh each of these pieces, it'll easily or pretty straightforwardly an application approach, a design approach. Now I have heard, well, microservices, you can write that well as a single developer. You absolutely can. But when we're architecting, when we're starting the system, are we taking these things into account, or are we simply going with our default answer? Because you can make all of these things work, but is that the best answer? The best answer for today and the foreseeable future? Maybe, maybe not. There are still times to build monolith systems that are not microservices. And if that kind of real-time stream analytic integrated system that I've got everything immediately available, the messaging overhead of microservices and the eventual consistency and not knowing whether something's fully completed, transactional boundaries, it might make more sense to build the monolith. There are still absolutely cases to build microservices that aren't cloud native. And there are absolutely times to build cloud native. As we look at it, we need to be weighing the business pieces that drive it, because the ilities that we care about from the earlier are going to change application to application. Now, this is one of my favorites. React or Angular, or Vue, or Knockout, or Backbone, or insert ad nauseum other things. The default answer I hear is, well, React, obviously it's way better, or Angular, obviously it's way better, or Ember.js, obviously it's way better. And it's typically the thing that they've got the most experience with. And there's a lot of value in that. But then there's some deeper questions as you start evaluating these pieces. You go, okay, where do we want navigation, business logic to live? If I don't want my navigation and my business flow to live in JavaScript, I want it to live on a server that can be directed so that my mobile app navigation and business logic flow is the same as my web app. It's an easier thing to accomplish unless I want to write it twice with an API directed application that's got kind of React components or Vue components than it is trying to do that with Angular. Can you do it with Angular? Yes. Is it the way Angular expects you to behave? No. Now, do I have significant and volatile workflows? Am I going to be changing those regularly? If so, I might actually need to layer in something else, like a director pattern or something like that. Do I already have a presentation framework? If I'm like, well, I got some APIs, but I'm pretty well good with anything, Angular might be a much more solid answer because it is an MVC framework for JavaScript. How much flexibility in the tools being applied do we want? Not in choosing new tools, that's a different thing, but in how you apply it. Do I want a less opinionated tool like Knockout or Ember, or do I want a more opinionated tool like Angular, like React. Good code in React does not look like good code in Angular because they have different idioms and different opinions. How much active community support matters? If I've got a team of JavaScript guys, they've been writing JavaScript since they started writing software, and they are mean stacked to the core. An active community really isn't going to matter so much to them. Whereas if I've got a bunch of Java or C# developers who are kind of first diving into this, and they're going to need a significant amount of support from the community and the ability to search for questions or ask questions, that's going to be more important to me when we're architecting a solution. And then do other applications need to talk to it? And if so, how and why? Do I need direct interoperability in which I can plug in and go? Okay, then I'm probably talking WebSockets and integration. Do I need state management? All right, React versus Angular, or is it React plus Redux versus Angular? Because React is easier to kind of learn very quickly than Angular as a whole. But if you add Redux, they're about on equal footing for the kind of speed it takes to learn. And so when we start talking about these different integrations, your choices become less about the obvious golden hammer solution and more about the one that fits the specific needs. And so ultimately we come down to, how do you architect for future frameworks when you know all the things are going to be changing? I was actually just seeing an email chain earlier today around the ability to take a Java applet and compile it into native code that's 50 times faster on startup, 50x, and uses significantly less memory because it transpiles down instead of to the JVM into machine code and native. That's brilliant when I need that level of optimization. But when I don't want the maintenance overhead. I don't want to have to worry about, is it compiled to this CPU or that CPU? Does it work with all the drivers, where the JVM does a lot of that for me? And so you get into these places where even the coolest solutions are the wrong solutions sometimes. So any questions?
Devlin, we don't have any questions right now.
Awesome. Well, I will say I am super excited about where 2021 is going, because it has a 1 at the end of it, and there's a happiness that comes to my soul in that. The other side of it is we've got some tools and some templates and some Word docs and Excel sheets and stuff that help to kind of guide through that evaluation. We call them assessments, but we can share that if you want to drop an email to devlin.liles@improving.com. I will send you those templates and you can use them internally. And it helps you to take what we've talked about here and go, here are some standard guiding questions that will lead me down this path. It's not going to make the decision for you, but it will guide you through the thought processes to consider those things in making the decisions on what tools make sense.
Devlin, thank you very much.
Thanks, everybody.
Thank you all for attending.
Have a good day.
Thank you all for attending today's virtual Lunch and Learn. And Devlin, thank you for sharing solution architecture for future frameworks. The recording of this session will be available the next business day. To view the recording, locate the session for Improving's virtual events page. And while you're on our virtual events page, be sure to register for future Lunch and Learn sessions. Join us on January 22nd, where Harold Pulcher will be presenting .NET 5 with a slice of Raspberry Pi. Have a great weekend.